Basically everything over there on the board is basically review, but that's kind of what we're doing now. You want to understand ratios of things like in the SOHCAHTOA, but you also want to know these identities also. And the whole point of all this is to simplify what we're looking at, to make something easier for us, okay, to handle. So the reciprocal identities over there, we should know those. The quotient ones, we've seen those before. If you don't know those yet, you should. We've had Pythagorean identities up on the board before. The first one is much more used, but essentially if you ever see a squared trig function, you should think of those identities. I think we did very briefly looked at cofunction identities, and we briefly looked at the even odds also. The even odd ones, that's kind of the definition of an odd function. If you plug in a negative value, it changes everything negative. Even ones, you plug in a negative, it becomes positive. So for the most part, this whole chapter is about those first three categories: reciprocal, quotient, and Pythagorean. Now, if you look at math as a very regimented thing, just give me the steps, then this might not be your favorite thing to do, because there's a lot of just like, what do you want to try? And so that means that there's a lot of ways to do all of these problems. But if you're okay with like kind of just playing around with things and plugging things in and trying things out, then this is going to be, you'll probably enjoy most of this chapter, because like that's what it's going to be. So that's basically the notes. All that stuff's in your book. Again, you should know most of it. Usually the way the cofunction ones work is like, when you know that's an option, it's really easy because you're like, oh, that's the only one that looks like that. But then what ends up happening is when you haven't used it for a while, you'll get to a problem, you'll be like, I have no idea what this is talking about. And maybe it's a cofunction one. Okay, so what are you going to do? All right, so I think the only way to go through these is just to show you what's going on. So I'm on page 463. I'm going to do some of your homework. I'm going to be doing some of the evens. And so this is number 1. And they're asking us to come up with all of the other trig functions. Now we can always draw a right triangle. Sometimes we're going to have to, but ideally we're mostly over here on the board. So if that's what we're given, and again we're trying to come up with tangent, cotangent, secant, and cosecant. So what's something we can say right now?
Cosecant is just going to be 1 over 1/2.
Okay, so keep, change, flip, or you can just think of reciprocals. Okay, so then cosecant is just 2. So that in the same way, we can find secant. Which would be what? 2 over square root of 3. Now you're never going to see it that way. So we should multiply by 1 and get over 3, right? All right, so we got those. So that leaves the tangent and the cotangent. Now if you're really up on, so you could draw a right triangle now, kind of like on the quiz. But if you're really up with it, like, and you can see those quotient identities, and that's where I want to be right now. So, use what you know to get these answers. But I want to look at what they're saying. So tangent is what? Sine over cosine. And so then sine over cosine, according to this problem, keep, change, flip. So I'm gonna, I want to keep an eye on this one. But then, yeah, multiply by square root of 3, over square root of 3. So then that would be, and I wanted to leave that one, I want to keep an eye on the 1 over radical 3, because now we can do cotangent.
So it'd be square root of 3.
Square root of 3. So again, this is going to help us simplify things later on. That's what we're going through. So I'll do, whichever ones you guys want. But so like more or less 1 to 14. I mean, I did number 10 with the other class. So let's do 10 also. Any questions on that so far? What's up?
In number 6 it says like cotangent of the
Phi, that's a phi. I think it's phi.
It's the same thing, it's another variable.
Yeah, it's all, they use Greek symbols because of trigonometry being basically started in Greece. So it's the Greek alphabet. That's why they could put X, they could put anything they want, but you usually see thetas and things like that because it's from ancient Greece. Okay, so some of this we can do by identities. We may need a triangle.
Sine's 1 over 5.
And why is sine 1 over 5?
Because it's 1 over cosecant.
Yeah, they're reciprocals. Okay. So now what?
You can make a triangle.
So this one I do think you kind of do have to make a triangle. What is this? What is this saying to us? Say it again.
The x is, the cosine of x is greater than 0.
So what does that tell for it? What does that do for us?
Tells us it's not negative.
What's not negative though?
X.
The x value. We know that the x value can't be negative. That's where we're really going. So like we need like, does it make sense if we need one of these two triangles to do these? Because like our unit circle values are,
It's gotta be on that.
it has to be on that side. Okay. All right, so then I got 2 triangle options. What do you want to do now?
Top one.
So what are we going to do?
I say just put a theta in the bottom one.
I'll put an X since that's what we're using.
Yeah. And then the opposite's 1 and the hypotenuse is 5.
And so then,
Adjacent to 5. Oh,
what is it? How do you find it? So then,
The 1 squared,
Should be
plus
squared.
b squared equals
so yeah, so 25 minus 1 basically.
Yeah.
So then, yeah, that's the square root of that, so 24. And so that simplifies, we could do 2 square root of 6.
Yeah.
Okay, so then, now we definitely have enough to go on. So what else do we know then?
Well, you could do,
Cosine would be 2 square root of 6.
Cosine would be what?
2 square root of 6.
2 square root of 6 over 5.
minus arc cosine.
Not arc cosine. No.
Look,
So secant. Secant. So secant would be
arc cosine will get you there, right?
arc. So you're only doing really arc cosines if you want to know the angle, but we're not worried about the angle right now.
Would it be 5 square root of 6 over 12?
So I'm gonna just write it out. I think that sounded right. So that's the reciprocal of cosine. Multiply top and bottom by square root of 6. Can we do tangent and cotangent?
Yes.
Tangent is, which one is tangent? Okay, because so like he's simplifying it. So it starts like that. Multiply by radical 6. top and bottom.
And then Joe tangent should be 2 squared 6.
Is that okay? We're just playing around with it, right? All right, so anything else from 1 to 14? All right, flip the page over. We're basically going to do the first, we're doing basically 15, 16, and 17, because I just want you guys to be aware of these, because it's a notation situation. This is back to limits. This is a limit notation. And so they say, this is 15 we're looking at. So they're saying, they say this. Do we remember what the arrow means on this situation?
It can go from X to pi over 2, but it cannot go back the other way, right?
You're thinking of this. That's an if-then statement. So no, so it's a little bit different. We've talked about this. It's been a while since we've talked about this arrow.
No use in signs. I don't know what they're called.
All right, so then it's read as x approaches whatever. So in this case, it's as x approaches pi over 2. But then they give you this little negative sign up here. So this is like expanding on it. So this is saying from the negative side or from the left. This ends up being important to us. And I'll show you.
Be on the left where it normally is, that's just toward -2 then?
That would be like, yeah, negative pi over 2. But then they put it up there, that's from the left. And so here's a picture. Here's a picture to kind of illustrate what's going on.
So if it's not up there, will it be a plus, or will it just not
Okay.
be there if it's coming from the right?
So let me write this out, and then I'll answer your question here, because it's a very important question. So that looks like sine from right. Is that close enough for sine? Okay, and so then this one is saying as we are moving down the x-axis from the left. So it's like we're cruising up here in this direction. Okay. If well, I'll do the. Let me answer your question after we do 16. Okay. So as we're moving in this direction, as x is getting closer and closer to pi over 2 from the left, what is sine of x getting closer and closer to? 1. Is that okay?
Yeah.
Okay, and so then they say, all right, well, what's cosecant getting closer and closer to? Why?
That'd just be 1 over 1.
Is that okay with everyone? It's just 1 over 1, it's just a reciprocal. Okay, so this is like kind of like, okay, so what? Like, what's the point? All right, so hold on. The point will appear on number 17.
Wouldn't cosecant be -1 though, not 1? Because it's opposite of sine.
So
Cosecant, if you graphed it, does it still look like sine?
remember,
Or is it underneath the
okay, so remember cosecant and sine, since they're reciprocals, we can graph them together. So like what we would do is say, okay, here, right, we can't have anything at cosecant here or here, because that would be where it's 0. We can't divide by 0. And so then this is what cosecant looks like right there, remember? Okay. Okay, so then, all right, so again, that's read as x approaches 0 now from the right, from the positives. Okay, and what are we looking at? Well, we're looking at cosine. Where is cosine going? Okay, so let's look at cosine here. Right, this is what cosine is.
Yeah.
So then now we're coming from the right. We're approaching 0 from the right, so we're coming in that direction. So then, right, so then it's approaching 1 again. Is that okay? All right, and then so then secant, what is secant approaching? 1, and it's the same, like, right, it's that U graph just there.
I had myself backward on that. I forgot that's what those look like.
Yeah. So again, so right now you could totally be like, so what? Like that's just what, because basically all we did was cosine at 0, and then we did secant at 0. Okay, again, so this is like leading us into limits. All right, so here's so what? So this is 17. All right, so let's look. So again, this is saying as x approaches pi over 2 from the left. All right, so let's remember what that looks like. So this is tangent, and this is pi over 2. Okay, so then as we're moving down this direction, what is tangent approaching? Infinity, positive infinity. Okay. Is that okay? Now, for the purposes of the next one, so I don't have to redraw it, like a different, like, so I don't have to redraw cotangent. Does this make sense that that's kind of what infinity would be?
Yeah.
And so now we can just say then that cotangent must be approaching what? 0. All right, so I still haven't got to the so what part. So let's think of what is tangent going to do as we move on.
Get closer and closer to positive.
No, like what's the next shape going to look like? That's not all a tangent. Yeah, it's just like here, right? It goes like this. All right, so now if I ask you the question, right, this isn't what you're being asked, but right, now if I said, what is, as x approaches pi over 2 from the positive side, so we're coming down this way now,
Negative infinity.
so then it's approaching negative infinity. And so this is important, okay? So when we get to, like, when we deal with limits, right, we say, like one of the questions is, does this limit exist at all? And so what we would do is say, well, what happens when we come from the left? And then what happens when we come from the right? And if they're the same thing, then we say, yeah, okay, so now it exists.
So like this one wouldn't be because they're here and here.
Yeah, so then, yeah, so like you wouldn't say, like the limit here doesn't exist, basically, is what
So
we're saying.
like this one, you could do tangent x, arrow, pi over 2, or tangent, like the other one could be to pi instead of just to pi over 2, and they'd be the same thing. So that would be a limit, correct?
So yeah, so like instead, like if we were just going to 0 here, you would say, okay, so the limit as x approaches 0, and so and this is what it would look like. So you'd say, okay, so the limit as x approaches 0 of tangent would be 0, because both directions give us 0. However, the one that we had, if we did limit as x approaches pi over 2 of tangent, you would say, oh no, they don't go to the same thing. One goes to positive infinity, one goes to negative infinity. Yeah, and so we would say it does not exist. Okay? So that's where all this stuff is going. And again, that leads us into some really big deals. Okay? And so the way calculus works is like you get this idea of limits. It's pretty straightforward. You got to do a couple things with it, but it's pretty straightforward. And then all of a sudden, because we can deal with limits, all of a sudden that opens the door for like all these other ideas. So limits are basically the foundation of calculus. And so we're kind of looking at them now. All right, so far good, so good. So you kind of don't have to do any of those problems, but I want you to get used to the notation, and that's what's going on. All right, so now I'm going to do 6 more problems, but basically you're going to do them. So I'm looking at 20 to 30. Okay, and I'm going to do the even ones from 20 to 30. And notice on 19 to 24, they give us 6 options of what our answer is allowed to be. And then 6 different options on 25 to 30. Okay, so this is all about these identities. And some people are going to be very much quicker about it than others. And I don't, we want everyone to like think about what to do. Okay, and so again, this is not one of our options here, right? We can be -1, 1, cosine, negative tangent, cotangent, or sine. That's what we want to simplify this thing down to. But we're using these reciprocal identities. And so here's things that we can look at. We could say, oh, cotangent is 1 over tangent. We could say that. We could say sine is 1 over cosecant. We could say cotangent is cosine over sine. And then any combination of that. So this, I would like.
Why is that simplifying it though? Because you're just adding more things to it.
Well,
right there's just 2 things instead of 4.
Right, but we'll use these ideas to simplify it. Because we're supposed to be able to simplify it to one of these 6 things over here. Okay? So again, this is like, every time I do problems like this, I always say my quote that I like from Winston Churchill, which is the best thing to do is the right thing, the second best thing to do is the wrong thing. Bless you. And the worst thing to do is nothing. So like, you may not choose the right way to do it first, but at least you're going somewhere. So like, what do you guys want to try to get this simplified?
Change cotangent to cosine over sine.
So he's saying like, okay, if we do this, he is predicting that this helps simplify it.
I feel like as soon as it would be cosine, sine over sine would just cross out.
So yeah, so he's saying like if we multiply these together, it'd be cosine times sine over sine. Those cancel. And then you're left with cosine. What's happening right now? They want you guys, not me. You guys are the ones that are going to change in 20 years. But I'll look exactly the same.
Except you'll have gray hair.
I will look exactly the same.
You got to deal with little kids at your son's soccer games. Dragging little girls in the bathroom, being like, is she alive in there? Somebody check on our little girl.
Yeah, we had a bad thing last night.
Oh no.
All right, hold on. Let's finish this, and I can tell you a little bit about it. All right, 22. All right, so this is more simplified. Okay. All right, so 22. Now, before you do 22, I do want to point out something. This is not what we need right now, but I do want you to start being able to think this way because this is coming down the road. You want to be able to identify just this part of it, as the difference of squares. Do we recognize that as a difference of squares possibility?
Not yet, but we will have to.
Yeah, you want to. And so then difference of squares, all it is 2 terms, both of which are perfect squares, and a subtraction sign in between. So we could factor this.
Wouldn't it be 1 plus cosine x, 1 minus cosine x?
Right. Now, this isn't going to help us on this problem, but I'm pointing that out now because that's coming. Okay?
Would it also work if that was 2 instead of a 1?
Can't take the square root of 2. It would work if it was 4, or a 9, or a sine squared, or a cotangent squared, or an x plus 1 squared.
So you have to be able to take the square root.
Have to be able to take the square root of it for it to work.
You can square root 1.
You can cube root 1. Yeah.
Okay.
All right.
You can any root 1.
You can any root 1. All right, but that's not what's going on this problem. I just want to point that out now. What do you want to do?
Could we, no.
And so I will say a hint, and this is basically telling you how to do it, but the hint is those Pythagorean identities, you can rearrange them. So for instance, the 1 plus tangent squared equals secant squared also means that tangent squared equals secant squared minus 1. Okay? Or 1 equals secant squared minus tangent squared. And so that's where we want to be. Or that's how we want to think, anyway.
So it could be cosine equals, or cosine squared equals 1 plus sine squared, or no, 1 minus.
1 minus sine squared. Okay, so instead of going that way, which would totally work, because then we could just substitute that into cosine, the quicker move would be to say, well, sine squared equals 1 minus cosine squared. Is that okay? Same way he was just doing it, just the other way. So then really this is sine squared times cosecant squared? Or no, just cosecant.
Which can change into 1 over sine.
So then sine squared times 1 over sine.
Which would just get you sine.
Is that okay? This is fun, right? Think how much fun this is. She whispering to me.
You change that in the tangent,
Probably. I wasn't going to do it that way, but probably, yeah. Yes. So this could be tangent. So there's a couple different ways. So this is, because it's just sine over cosine, as long as your inside the parentheses are the same, we could call this tangent of that. No, not tangent of x, just tangent of that. Now, that's not one of our options. So this is a cofunction one. So then this is just cotangent. Is that right?
So you could also be a, or. any
Correct.
other
Yeah, it's just a matter of anything, yeah. This reminds me of Saturday nights in college, man. Takes me back. Way back. That's a long time.
How many math classes did you have to take in college to be a math teacher?
I don't know. I had a mathematical sciences major before I was a teacher, so I don't know. Probably too many. What would you like to
You
do?
could do cosine is secant over, or 1 over secant.
We could do that. So again, there's a lot of ways to do these. So let's see where that takes us. 1 over secant squared. It'd be 1 over secant squared. Yeah, okay.
Because cosine squared already.
So you could do that also. But this works because now what could we do?
Just multiply them.
Okay, so then when we distribute that, the first term would be 1 now. And then minus 1 over secant squared. That's not one of our options for this one, but how can we rewrite 1 over secant squared? So 1 over, I think it's cosine squared, isn't it?
Oh, yeah.
All right, that's still not one of our options, but we're pretty close.
So that could be sine squared, right?
So then, yeah, sine squared, and I think that's one of our options that we could be. Yeah.
Could you change the secant squared x minus 1 into just tangent squared?
So yeah, so a lot of different ways that you can go about that, right? So you could definitely start up there at that secant squared minus 1, because that would be the equivalent of tangent squared. So we could have just changed that to tangent squared right here. Then we could rewrite tangent squared as sine squared over cosine squared. There's the cosine squares cancel. We're still at sine squared. So yeah, a bunch of different ways that we can go through these, okay? That's what makes it so exhilarating. That was correct. Yay was the right statement.
You just do the same thing. Change secant to 1 over cosine and then cosine over sine.
Okay, so 1 over cosine, right? Cotangent is what again?
Cosine over sine.
Cosine is canceling back to sine.
Yeah, 1 over
1
sine.
over sine.
Yeah, 1 over sine. Yes.
Isn't that nice?
That is kind of satisfying.
Yeah, it's kind of nice, isn't it? Yeah. It's not bad. Like, right? Like, what?
Oh, this is
I laugh at no one's face because Donnie was like, that's kind of nice. He was like,
That's how I used to pick up the ladies. Little shit, yeah. I'd say a little bit smoother than that, but yeah, basically. Be more like.
Wanna watch me change coach agents?
Now you're getting there. Now you know what I'm talking about, yeah.
Oh, God. That'd be a great pickup line.
Yeah, it's basically like, you want me to simplify some,
Do you wanna
It's
go
almost
to
a
work before
tattoo
I
on the
leave, or just wait till
forearm.
Friday? Okay. Have a good day.
yeah, you too.
Want me to change this equation to make it cosine of x?
You should look up, I'll be like,
I can
let's
change
get out of
this
here.
equation.
Strangely, they never came. They would just sit there still like, is this going, who is this guy? It's all about confidence.
Can you just make it cosine of
No, because they're not the same things in the parentheses. So you can't cancel cosines on this one.
Well, that's equal to sine.
Sine squared, right? So yeah, so then we could say sine squared up top.
So function of x.
Oh, yeah.
That's not one of our options, so we gotta go further.
I was gonna say that we could just divide them, like keep, change, flip, but that doesn't do anything, cause then it's just the same thing again, just upside down.
Yeah, kinda, yeah. That's not one of our options though.
You're just changing the tangent.
So we could rewrite this as sine x cosine x times sine.
Changing the tangent times sine.
Tangent times sine, and that is one of the ones we can be.
I was so confused on how you're gonna change a sine squared into cosine. Or
Could you
something. I was
have
like,
also
it says sine
done-
x tangent.
Turn cosine into 1/secant, and then, what does that do? Oh, yeah, no, never mind,
So,
just juggling things at that point.
but that's good. Like, so like you gotta try stuff. Okay, so like it's not always gonna just pop into your mind, especially like, there's, there are 6 of us doing it now, or 8 of us, whoever it is there, right?
Well, there's, 20 some options you could do
Right, yeah.
100 times.
Yeah, right.
Different things.
Yeah, let's do some probability. Now you're talking, man.